Okay, so now let's go into some examples. A random sample of American college students was collected to examine quantitative literacy, so how good they are at reasoning about quantitative ideas. The survey sampled 1,000 students from four-year institutions. This was the mean and standard deviation, and 800 from two-year institutions. Here's the mean and here's the standard deviations. Are the conditions for confidence intervals met? Are the conditions met? Also construct a 95% confidence interval and interpret it. Okay, so let's think about the confidence interval requirements, right? So first is independent random samples. So it does say random sample, right? And these are independent populations. One is four-year institutions, one is two-year institutions. There are very few people going to both of them at the same time, right? So first one, check. Second one, can we assume normality, either because of a large N or because we know that both these populations are originally normally distributed? Well, they have pretty large N's, so I'm just going to say, number two, check, right? Number three, is this sample roughly sampling with replacement? And although 1,000 students seems like a lot, there are a lot of college students, so I'm pretty sure that this meets that qualification as well. So go ahead and construct the 95% confidence interval. Well, it helps to start off with a drawing of my SDOD, just to anchor my thinking. And this mu sub x bar minus y bar, right? We could assume that this is x bar minus y bar, right? Because that's what we do when we do confidence intervals. We use what we have from the samples to figure out what the population might be, right? Okay. And then we want to construct a 95% confidence interval, right? So that's going to be 0.025, 0.025, right? And then maybe it will help us to figure out the degrees of freedom so that we'll know the t value to use, right? So let's figure out degrees of freedom. It's going to be the degrees of freedom for x, and I'll call x the four-year university guys, and the degrees of freedom for y, the two-year university guys. And so that's going to be 999 plus 799. Right? And so it's going to be 1,800 minus 2, so that's 1,798. Okay, so we have quite a large degrees of freedom, right? And so now let's find the t for this place. So what we really need to find is this and this. Let's find out the t first. So this is the raw score. This is the t. Let me delete some of this stuff. Just makes life a little complicated. And I'll just put x bar minus y bar in there, and we could find that later. So the t is going to be the boundaries for this guy and the boundaries for this guy, right? So what is our t value? Well, you could look it up in the back of your book, or you could do it in Excel, sorry. Here, we want to put in the t in because we have the probability. And remember, this one wants two-tailed probability, 0.05, and the degrees of freedom, which is 1798. And we get 1.96. We'll put 1.961 just to distinguish it. 1.961. Negative 1.961, right? And so let's write down our confidence interval formula and see what we can do. Confidence interval is going to be x bar minus y bar, so the middle of this guy, plus or minus the t, which we now have, times the standard error of this guy. So that's going to be S sub x bar minus y bar, right? And so it would be probably helpful to find this thing. So x bar minus y bar. So x bar minus y bar. That's going to be 330 minus 310. Oh, I didn't need the calculator to do that. And let's also, while we're at it, try to figure out the standard error of S dot, which is S sub x bar minus y bar. Sorry, this is terrible, but hopefully you know what I'm talking about. So what I'm trying to do is find this guy. Well, in order to find that guy, let's think about the formula. This is going to be the square, and I'm just writing this for myself, the square root of the variance of x bar, right, plus the variance of y bar, right? And we don't have the variance of x bar and variance of y bar. So let's think about how to find the variance of x bar. Well, the variance of x bar is going to be s sub x squared, right, divided by n sub x. And the variance of y bar is going to be the variance of y squared divided by n sub y. Right? Okay, so I wanted to write all these things out just because I need to get to a place where finally I could put in s, right? And finally I could do that. This is s sub x, this is s sub y, right? So I could put in 111 squared, right, divided by n sub x, which is 1,000. And I could put in the standard deviation of y squared divided by 800. Right? So now I have these two things, and what I need to do is go back up here, right, and add these and square root them. So square root this plus this, right? Because I know that this equals that equals that, ta-da. Okay, so we have our standard error, which is 4.49. 4.49, and this is 20, right? Plus or minus, t is 1.961, right? So now I could do this, and I'll just stick that in my calculator as well. So the confidence interval for the high boundary is going to be 20 plus 1.961 times 4.49. And the confidence interval for the low boundary is going to be that same thing, except I'm just going to change that into a subtraction. And so 11.20. So let me move this over. So it's going to be 28.8. Let me put the low one first. So the confidence interval is from about 11.2 through 28.8. And now we have to interpret it. This is the hardest part for a lot of people. We have to say something like this. The true difference, so the true difference between the population means 95% of the time is going to fall in between these two numbers, Or we have 95% confidence that the true difference between the two population means fall in between these two numbers.